Hi, everyone. Welcome to Foresight Space Group. It's very good to see so many of you here in the room. And then afterwards, also, if you're watching, I'm getting so many emails that find these space conversation really, really interesting because we have so many brilliant minds on here that have been in this industry for so long. And I think it's very rare that you get like a view behind the scenes. So thanks everyone for providing this here. I just want to mention one thing, which is that we have a workshop coming up in our space group. And so to provide some more info on that, on our website, I'm going to share it here as well. We have the space workshop coming up later this year, in a few months from now. And it's going to be at 50 years in San Francisco. So for those of you who are interested in joining, please, please, please do apply. Or if you're in this group, just email me directly and I'll make sure it happens. We have wonderful presenters already. And it's going to be a mix between near-term challenges within the space industry and long-term goals that we want to get to. So by all means, please, please, please join us. It's a really wonderful way in which people in this group can also get together in person, because I think that's ultimately when the best long-term collaboration happens on the difficult problems that we can only touch on kind of on the surface here. Anyway, that's all for me. Thanks, Creole, for stewarding this conversation. And thank you so, so much, Jonathan, for joining us today. I'll be in the background and I'll give it over to you, Creon.
All right. Well, this is an interesting guest we have today and an interesting situation we're going to be exploring. And I'm really glad, Steve, that you're here, Steve Jurvetson, because this is a great contrast. I don't know if you know about Jonathan, but this is a great contrast. It's going to be our second collection that we tour or talk about, but it's different than yours. Steve's collection, of course, is physical artifacts of the historical space program, right? And that's just a small fraction of them there. And he did a great tour with us. Anyway, that is already there. It's available on the YouTube channel if you want to see it. And today we have the great good fortune to have Jonathan McDowell presenting. And Jonathan also has one of the major space collections in private hands in the world, but it's of a different nature. It's physical artifacts, but they are primarily informational. And I'm going to let him talk about his library, and I'm going to interrupt him occasionally. So here's what happened. Rather than give a walking tour of this thing, he elected to make a video, but it's 15 minutes long and I think it might be a little bit too detailed for some people, but it's a valuable artifact in and of itself, a sort of meta artifact of the tour of the other artifacts. And so we're going to put that link to that video in the show notes. And then he also prepared a set of slides with still images and text to sort of guide the tour in that way. And so I think we're going to have him share his screen, walk through his collection and his commentary. And I think that unlike maybe some previous sessions, maybe we can all, since it's a pretty small group here, we can freely interrupt and ask questions at will. And I'm going to start it, though, before we get into the tour, Jonathan. I want to ask you a question, which is like the very quick 30-second description of what you're going to be talking to us about today. And then like maybe the 2-minute description of how you got started, because that's not included in your materials, how and why you got started.
Yeah. I mean, so I got interested in space as a kid during Apollo, but I was growing up mostly in England, and I was really frustrated that it was hard. The media didn't care, right? And it was hard to get information about what was happening in space. So I had to do my own research, and I started collecting. I started making lists of what's been going on in space, and to sort of back up that list. So I've been working on that list for about 50 years now, and it's now, I think a lot of people feel it's the reference list that people go to of what's happened in space. And so backing that up is the library behind me, which is the documents that I've collected from all over the world to help me try and understand what actually happened in space and the frustration.
Well, count a second, Jonathan. Let's mention that the library behind you isn't what's shown on screen. The library behind you is about like 12 times as much as what we can see on the screen.
It's currently about 1,100 linear feet. It's about 50 bookcases, something like that, maybe 100. And so, yeah, there's an enormous amount. And I'll show a couple of pictures of that in a bit. I've been collecting it, as say, since I was a kid. At one point I had to buy a bigger condo to fit it all in. And so the point is, when professional historians, when they write about space, they write a book about some particular space program, and 90% of the book is about the politics of how it was funded, which is all really important, but the actual launch and what happened in space is sort of the last half chapter. And so I wanted to actually do a better job of recording for the future what these missions have actually done, what really happened after launch as opposed to what was planned. Because a lot of you are involved in missions, right? And you go, you a stack of paper you need for PDR, CDR, getting ready for launch. And then at the end of the mission, when you're switching the lights out and moving on to something else, you're lucky if you get a one-page memo. And so I've tried to collect that sort of post-launch information. And that's really the motivation, is to preserve that for the future. And so I started as a 12-year-old. I found the list of space launches in the back of James Aldwell's aircraft, and I copied it down. And then I realized it wasn't very good and I could do a better one. And so I set off on this rabbit hole. Let's make a better list of all the things that have gone to space. And so that has ended up as the general catalog of space objects on my website. And the physical library is the material that backs it up.
Okay, so do you want to start into your slides at this point?
Now, let me try and share the screen and see if we can make that work. And so here is the document.
By the way, when he says share his screen, that's more complicated than it even is for most of us, because he's got about 8 of them.
That's right. So I have to put the PDF on one of the smaller screens so it doesn't distort fuel. Can you see that now?
Yes.
So yeah. So what is my library? Well, here's a few views. This is one of the bays of the library. This is actually a bit of an old photo. It's grown since then, but you sort of see I have stacks, and there are all these binders, and each binder contains data on individual launches that have happened both orbital and suborbital. And so here's another couple of bays looking out toward the living room. And so you can see that there's a lot of these. And as well as the binders, I have a pretty good collection of monographs. Most of these are the NASA special publications, and I've acquired a pretty comprehensive collection of these, particular thanks to the MIT Aero Astro Library for putting a whole bunch of their stuff in a dumpster that I managed to salvage. And then the view of the outside of the library, I have, so on the left here, there are so some of these binders of launch information and going into the stacks in the back. On the right, there's a whole set of shelves with periodicals and a lot of pretty rare space periodicals. And then a whole bunch of...
Jonathan, sorry to interrupt. I mean, I think you might be going a little too fast here. Are you going to go back and do some detail on the organization of the library and completeness?
I can do that. Yeah. So I just want to give you sort of overview first of the scope of the thing, and then I'll call out some of the particular treasures. I think that might be the way to do it. So it's sort of launch information, periodicals, and monographs. Actually in science fiction, which you see on the right here, we'll just skip over, but all these blue ones on the middle left here are European Space Agency special publications. And this is, I think, there are very few places in the world that have a good collection of these. Even some ESA centers don't have them. And then here, on the right of that, there's a bookcase full of space histories from different parts of the world. So starting on the top left there with Australia and Argentina, and going down to the UK alphabetically, and then behind, heading off into the distance on the right, a huge collection of Russian space data, both English language and Russian language of what's happened in the Russian space program. And I also have other things. I have a whole bunch of astronomy data, and then I have a section on human spaceflight. And so this bookcase contains Mercury, X-15, Gemini, Apollo, and Shuttle. And again, each binder we'll see it has or some launches for Apollo. There's 5 binders for one Apollo mission. Some data from the internet, but some Xerox from archives. And so the scope is, as I said, what actually happened in the exploration of outer space, what rockets went up, what satellites went up, what did they do? And so all the general collection in my 1900 square foot apartment, we have about 350 meters or so, 1140 feet of stuff, which is a pretty good binder. And so what do I do with this? It doesn't
Okay,
just
hang on a sec. Are we going to go back to more detail after all this?
Well, yeah, I just try to give you context. Yeah, so I've had this monthly internet newsletter since 1989, Jonathan's Space Report, where I say what's going on. I have a website with the big collection of list of satellites, list of rocket launches. And if you're on Wikipedia and you're looking up a particular satellite, if you follow the chain of references, most of the time it eventually comes back to my website. So I'm going to skip over some of this. Show you. So here is, for example, some of the binders of the launches, and the launches are organized alphabetically by rocket. And so here's some of the Thor Regina rockets. And so this binder here is launches number 85 to 87. You open it up to a particular launch, which is a Corona spy satellite mission from 1963. And so I went to Vandenberg Space Force Base and got this page on the top right, which is details of the launch process as reported at Vandenberg the day after. And then also I went to the NRO in Virginia with their nice declassified documents trailer and the nice gentleman with the machine gun standing behind me to make sure I didn't Xerox the wrong things. And this is CIAO photographic evaluation report showing at the bottom right the paths of this satellite as it went over the Soviet Union. So I collect from many different sources all the different public pieces of information, all open source, nothing that's still secret, and organize it by launch so you can find all the information on one launch in one place.
Question, Jonathan. Do you have some really skinny binders with what you can find in the open about classified missions, or do you just skip them entirely?
No, I have skinny binders. And when I say open, I'm including open source analysts figuring out what they're doing, even if the NRO won't tell us. And so I usually have something on most things, even if it's just hobbyist observations or a launch announcement in a newspaper or the UN registration filing. So here, for example, is a piece on the Soyuz T-10 mission in 1984. And there's an article from Spaceflight magazine. There's an article from a Russian magazine. There's a copy of Pravda that I picked up at the time with the biographies of the cosmonauts, and an extract from Novosti Kosmonavtiki magazine, which is this amazing magazine that for 20 years was giving. If you don't know about Novosti Kosmonavtiki, it was sort of like the best space magazine ever until Putin shut it down, and has really great details on particularly the historical stuff on the Russian space program. I went to this French space agency, CNES, in Toulouse. They gave me a very nice tour of the control center. But then I said, okay, just leave me in the basement with the Xerox machine. And I managed to find this listing of all of the French suborbital sounding rockets that they had in a binder. So I Xeroxed that. And so that's now part of the big launch list. So really collecting from everywhere in the world, including suborbital missions. This is an Aero-B sounding rocket flight in 1963, where I have the press release, but I also have the scientific paper published afterwards that gives the results of that rocket. And those are not well tied together often in the literature. So here's one from 1963 with a suborbital flight of the Nike Cajun rockets. So it really includes all of the suborbital as well as the orbital. This is a set of binders on the Japanese H-2 rocket with sort of handouts and press kits and so on from each launch. And so that sort of gives you a sense of the main part of the collection.
Well, can you go back to the serials for a moment?
The serial, yes, right.
So I think you should say something about that, because I watched the video and I kind of know one level down from this. That's a unique collection, is it not? Could you say something about how that is?
Right. And so one of there are several, I mean, I have a complete collection of space news, a complete collection of Aviation Week. Those are really easy to find, right? There's even a complete collection of the British Interplanetary Society Spaceflight magazine. That's not too rare. But then I have some things that are a lot more rare. I have a complete collection of Missiles and Rockets magazine, which is a sort of Aviation Week-like trade industry magazine from the 1960s that has lots of really great stuff in, including some absolutely amazing ads for buy your new rocket here. I have a bunch of Russian stuff. There's something that started off as like a samizdat, that fanzine, a Novosti Kosmonavtiki. And it was originally just sort of Xeroxed and really poor quality. And then they got some Russian Space Agency money. It became very glossy and fancy. There's a set of European Space Agency bulletins. I have a set of the NASA Goddard Satellite Situation Report going back to the 60s. And so there's a lot of really obscure stuff with a lot of data in it that you're not going to find in most libraries.
Okay. And I guess I'll keep asking questions unless someone else wants to jump in. What is the accessibility of this library to people other than you?
Let me just stop sharing as we're chatting. Yeah, so I do have occasionally people come to do research. So for instance, I don't know if any of Dave Stumpf, he wrote the classic book on the Titan II missile, and he just published a great history of the Minuteman missile. And so Dave came and stayed with me for 3 days to do Xeroxing and research in the library. I have shorter term visitors that come by and look up specific things. So I'm very happy to have sort of research visitors, and I like showing it off, right? So, and people who come around and just want to see it and browse, I'm happy to do that. A few people have come in the past couple of months, including a lad called Will Marshall that some of you know. And so yeah, definitely if you're in the area, if any of this group is ever in the area and wants to come by, very happy to have you come visit and show you what I have.
Do you have any co-conspirators locally who help you or work with you or any of that?
Not locally, not in that sense. There's a network of us across the world. I have my sort of Baker Street irregulars who feed me stuff. And there's a few of us across the world who have these websites. I mean, Gunter Krebs in Germany, Vladimir Arkhipov back in the day, pre-Putin in Russia, and Asif Siddiqui at Fordham, who's a guy that if you don't know, he wrote the Challenge to Apollo book about the Soviet moon program. And so we exchange information on a regular basis and help each other out. And so the people who really care about getting the finicky details of exactly what was that launch time or what was the difference between these two rockets and so on.
Oh, look, Ron Turner has a question. It's a great question, a question I sort of wanted to ask as well, which is,
Index.
yeah, right. So this is something you showed in your video. I don't know if it's possible. Do you have, your list, talk about your list. And then maybe if you have a picture of it or a screen you can share, I guess.
Yeah, I'll share that in a second. Let me just bring that up. Let's see. So there's a number of ways I got to go. Let me just talk a little bit around how I index it and keep track yeah, I had my own sort of equivalent to the Library of Congress system that I made up for topic numbers. And so every binder has a little number on it that helps me remember where to shelve it. And then the whole library has a spatial organization, makes sense to my warped brain so that I can pretty easily locate things. All of the main part of the collection is the launch collection, and that is alphabetical by launch vehicle. And so if I want to find a particular satellite and I don't remember off the top of my head which rocket launched it, I go look that up, what rocket launched it, and then I can quickly index in to the binder for that rocket in that year. And so if I'm going to have to make a really big screen because this is a very wide file, and then let's try sharing it again.
Yeah. So another thing I want to say while he's hunting around is that I know that one of Jonathan's many priorities, but a big one with this collection, is to have a complete list of the launches that have happened. And, oh, there we go. And like all the details of the launches, not just from the US Space Catalog, but all these additional details, so that maybe you could describe what is your goal in having this list of all launches historically, and not just their orbital elements, but their metadata? Why do people care about some launch that was the orbital elements of something from 1967 or something like this?
Yeah, it's amazing how these things come up. I mean, one thing, right, is that you want the long-term statistical summary. And so you want to know how much mass was launched into space in 1967 compared to today, for example. And so that's something where, to know that, you need to know the individual masses of all the individual things. You also, sometimes it comes up, well, there's a declassified NRO statement now that says that this NRO satellite passed close to this other Russian satellite, and we were wondering whether it was looking at us. And so being able to go back and get that orbital data and actually do the orbital propagation and show when and where that happened, or which satellites were in a position to take photos of Skylab when the solar array wing was broken off. And so that kind of stuff, there's all kinds of historical queries that being able to reconstruct the mission, being able to say 50 years after the fact, oh, these two satellites passed within this distance of one another, or this satellite was indeed over this country at this time. Just every week I get some query from someone that makes me have to dig into the archives and see what's going on. And so, all right, so now you can see this satellite catalog entry. I just want to sort of illustrate the last couple entries here are from the last Falcon 9 launch, which left two objects in orbit, the Intelsat satellite and the Falcon 9 upper stage. And what I have that isn't in the regular SatCat is, see, about halfway across, you see this sort of date, April 7th at 05:02:22, which is the time that the satellite separated from its parent object. And its parent object to the left is actually the Falcon 9 upper stage. And so I have traceability of when something separated from something else. I have an owner, Intel U, off to the right there. That's the US part of Intelsat, and a manufacturer, MaxSS, which is my abbreviation for Maxar Space Systems. And there's a whole separate organizations database that ties these tags to the operating locations that own and build the satellite. And then, and that organizations database, I think, is actually quite useful to people. It does things like it gives you traceability to the fact that the current Maxar Space Systems is the former Loral Space, is the former Ford Aerospace, is the former Philco Ford, and so on. You can trace back that corporate history at the operating location level. So,
by the way, one thing which I have not used your library for, but now that I know about it, I may very well. I'm busy trying to trace back and get interviews with some of the designers of the now declassified NRO Earth observation satellites, surveillance satellites, and the companies they work for are now absorbed multiple times by other companies, and figuring out how to get a hold of these people is a bit of a chore.
Yeah, for sure.
They're still alive.
Hey, they're still alive, and they're probably retired, almost all of them. But there is there was a good.
Yeah, sorry, I had to interrupt. Philco Ford. This is 1967 SkySat 1 solar panel spare from Philco Ford, just to
very nice.
illustrate what you were just saying.
Yeah.
A lot of using it like a show and tell mask. It's quite nice.
Right. And so being able to take that and go, okay, I know what Philco Ford is. I know it's in Palo Alto. I know that its air now is Maxar, or whatever this week's owner is. And so having, and one of the things about that is there are so many different parts of Boeing, right? But some of them used to be McDonnell Douglas, and some of them used to be this, and some of them used to be that. And it makes more sense to me to trace the operating location because the design heritage tends to go with that at that level of granularity. So it's getting the right level of granularity. And so I just mentioned that on the right-hand side of the screen here, I've just sort of scrolled over to show various masses, various dimensions, and a representative set of orbital parameters. But then, and do you know what that Philco Ford solar panel, do you know what satellite it was from?
Yeah, it was from SkySat-1, which is pretty cool.
Is that?
SkySat-1 for the British. Yeah.
Oh, Skynet.
Oh, Skynet. Excuse me. I said SkySat. I got Skynet. Even better name. The freaking
right.
original Skynet.
Yes, exactly.
Military comm system in the sky that can never go down.
It is. I hasten to explain to everyone whenever this comes up that the RAF's use of Skynet for their satellite predates James Cameron. But the first one was launched in 1969. And so now I hope you can see on the screen that entry 4250 for Skynet 1A.
Oh, that is so cool.
Launched in 1969, separated from the Delta 74 third stage at 0102 UTC, and is still in orbit. And so that's all very well, but that's just...
That last point is really interesting. It's still in orbit, which is, there was some orbital change maneuver that left it up there like possible space junk.
Well, so we found that it was 4250. So if I just, okay, that's a problem.
Hey, by the way, Steve, if it's still in orbit, how are you handling its solar panel?
It's a spare.
Okay.
Yeah.
Oh, by the way, if anyone wants one, the guy who sold this to me, I bought it by auction. I think he has at least 3 or 4 more of them. So if someone that would be so cool. It's very lightweight. It looks really cool. And it's historically.
Did you stick a voltmeter on it? Put it in the sun?
Well, it probably still, it got some cracked cells, but it's still got the wiring and the diodes. So yeah.
So if I go to, I'm just remotely logging on to my proper computer so that I can actually get this. So then I can very quickly derive for 4250 the orbital history of this satellite, which is pretty spotty in the early years, but since it was well tracked for a while in the 70s in a geostationary orbit at 107 degrees west. They lost it again for a while after it was retired, but then in the late 1980s, they got it back again. And so we can track each one of these as a separate TLE, a separate orbital data set. And so you can see that today, in April 2023, the last data set was yesterday. And it is actually not only still in orbit, it is still kind of station keeping at 104 degrees west on the right here. And it's a bit of a cheat because 104, 105 west is a little bit of a dip in the Earth's gravitational field.
That's an attractor point.
Is it almost like a Lagrange point?
But it's a energetic minimum for an object in geostationary orbit. So they all collect there after they're non-maneuverable.
Right, exactly. And so what happens is that the Earth is not cylindrically symmetric quite. There are lumps, and those lumps in the gravitational field cause unpowered geostationary satellites to kind of slide around the ring and collect either over this 105 west kind of location or over the Indian Ocean, or 2 minima.
They tend to, of course, in a way, orbit around those points. They go back and forth. They're like, it's a very shallow minimum.
Yeah. There is another Skynet 1 satellite that was launched the next year, 1970. And that one, I think, has been lost because it was a launch failure. It got into orbit, but it didn't get into the right orbit. And so it was left in an orbit with a 10,000 kilometer perigee instead of a 37,000 kilometer perigee. And the apogee motor exploded. And so it's been lost. So it's up there somewhere. And I'm kind of surprised that it hasn't been recovered.
What about, so to pivot just briefly, these TLEs are all nice, but since you do every mission, what do you do about deep space missions and how are they cataloged?
Right. Well, and that's been one of my particular passions, is making the deep space catalog, because until very recently, Space Force totally didn't care about anything that far out. And so I have assembled the catalog of things that are space junk in deep space that is either, that doesn't have, a lot of it doesn't have Space Force catalog numbers, even much less orbital data. And I have gone through archives collecting the orbital information. And so, for example, I'm going to take a risk here. If I look at a 1978 mission, Pioneer Venus Orbiter, I've collected orbital data that gives the hyperbolic orbital elements of the Earth escape trajectory, the solar orbit orbital elements of the transfer orbit between Earth and Venus, and then a few. I don't have much data, but I have some data of the orbit it had around Venus after it entered Venus orbit, and I'm hoping someday to find the treasure trove of like the full ephemeris data of that mission that I can get a better time resolution on this. And so that means that my software has to handle an extension to the old TLE format that knows that this thing is in orbit around Venus, and or this thing has an eccentricity greater than 1. And so all of my software, unlike most satellite orbit software, does handle these cases of you're not just in a Keplerian orbit around the Earth.
Hey, a little tidbit on Pioneer Venus. Venus was still being operated and doing science when I got to NASA Ames in the 80s, and for a few years after that. And I had a very good friend who was basically the controller for Pioneer Venus, who figured out did all the commands based on the scientists' goals for what instrument they wanted to enable, and on the satellite engineers' information about what the commands should be to execute, to change whatever it was they needed to change on the satellite, the orientation, the power systems, the data systems. And I want to tell one very quick story about that because it's rather interesting. So Pioneer Venus operated for a very long time. And they had to keep these old Xerox Sigma 7 computers alive in the lab until it was decommissioned. And unfortunately, Jonathan, they probably threw out all the documents which would give you the data you want to know. But be that as it may, or at least certainly they threw out the disk drives that had the real data. But one of the interesting things about that is that, so as you may know, if you have a satellite and you want to do a maneuver, and they used, of course, wheels and little thrusters, little hydrazine thrusters to do their attitude change maneuvers. The thing that can happen, like the worst thing that can happen, is you tell it to fire the engine for a certain short burn to maybe change the orientation of the satellite because you want a new instrument pointed at Venus. And the worst thing that can happen is that command gets corrupted, and instead of a 1 second burn, it becomes like a 1,000-second burn or something like that. And then the motor would go on and it will exhaust the fuel. It will exhaust the propellant. It will spin up the satellite. And now it's like mission over because you're never going to get it to despin and make any more maneuvers. And so this was my friend who did these commands. If they wanted to do a 1 second burn, here's how they would do it. They would send up the command for a 1 second burn. And then they would also send up with it another command, which sets a timer independently. And when the timer expires, it sends a priority interrupt to shut down the motor, no matter what the motor thinks it's supposed to burn for. And then they would send from the ground at the exact moment necessary to compensate for the light travel time, an even higher priority interrupt command that when it arrived at the satellite would shut off the motor, so that even if the first two things failed, this triply redundant command would shut the motor off, because the last thing they wanted to was have the motor burn out, basically. And what he said to me, I'm not sure how they knew this, was that all combinations of two of those three redundant commands had failed, but they never had all three of them fail.
Yeah, well, it's amazing what will bite you in these missions. Talking of Ames, right? One of the things so I got the data here for Pioneer Venus Multiprobe. This is the second mission, and just to show you, this is the binder for Pioneer Venus Multiprobe. This is the binder for Pioneer Venus Orbiter, and so I got a lot of documents on it. One of the things, but I have found one crucial bit of data for the interplanetary orbit of PVM, which I hadn't been able to find anywhere. I went to Ames, I went to the archive, I dug through the archive for a day, and I found a telex on which someone had written down in crayon the state vector. of the thing. And that is my only source for the orbit of the Pioneer Venus Multiprobe Centaur, is that crayon state vector that I quickly Xeroxed and took back here and then number crunched. So I'll just mention for the upper part of this screen now, I listed all the objects from the, let me do it again, actually, just as beginning with, so in the catalog, there are actually two catalog numbers in the Space Force catalog for Pioneer Venus Orbiter, the Pioneer Venus Orbiter and its Centaur rocket. I don't know if this is big enough that you can see it on people's screens.
I can see it if I close out all the other windows.
Yeah, I wish I'd had all. Yeah, and a bit bigger, but no, that's not gonna help you. But there's also, I record some suborbital objects: the Atlas booster section, the Atlas first stage, the payload fairing halves, and that lets me reconstruct what specific configuration of the rocket was used for that mission. But I also have, in what I call my auxiliary catalog, two other things. One is the motor used for the Venus orbit insertion that you mentioned, and the other is an ejected object, the orbiter neutral mass spectrometer cap, which is a tiny little thing that got ejected from the mass spectrometer. And that's not in anyone else's catalog, but there's a paper that talks about the fact that they ejected it on this particular day, just before I think they went into Venus orbit. Let's see. 00587.
Steve, let's interrupt for a second. Steve, what have you got in your hand?
It's Pioneer Lunar Orbiter Probe, and I forgive my ignorance because I haven't done my work on this yet to know if there's any relation to the Pioneer Venus.
Pioneer Lunar Orbiter Probe? That be one of is that one of the 1950s one, like the Atlas?
58. Yeah, it was.
Yeah, the Pioneer program was like kind of a catch-all, right? And it became an Ames project in the mid-60s with the Solar Pioneers. But before that, there were actually two separate Pioneer programs. There was an Army/JPL program led by von Braun and Pickering. And there was an Air Force program, Project Able.
It was this one, I believe. Valid Able.
You're talking about Project Able.
59 and beautiful looking, right?
No, they were amazing things. Unfortunately, they almost all failed. They were a great try, and they have no relation to the NASA Pioneers that came later.
Gotcha. Sorry about that.
Pioneer 1 through 5 were Army and Air Force, even when they were rebranded as NASA when NASA was invented. And then Pioneer 6 onwards were NASA Ames, and they were really unconnected. But they had the one successful one was the final Able probe was Pioneer 5 in 1960. The final one that got anywhere. And that was one of the first solar wind study probes that was just it was originally built as a Venus probe. They missed the window, and so they just launched it in orbit around the sun to study the solar wind. And those were some of the early missions. The Air Force ones, the Ables, were also TRW. And so they were some of the early TRW missions.
Is this catalog available outside of your condo?
It absolutely is. And so it is on, let me just, I'm going to stop sharing that window. And it is the general catalog of space objects on my website. Finding, I'm going to say it. All right, come on.
Hey, John Karsh, are you at NASA headquarters these days?
I just finished the detail there. And so I am back at Ames, but just virtually.
Okay. Well, I really wish Alex McDonald had seen this, but maybe
we can egg him on to watch the recording.
Yeah, that's what I was going to say.
Exactly. Yeah.
Has Alex McDonald ever been to your home, Jonathan?
No, he hasn't. There are a few sort of relevant people who've been, but I keep trying to get people like him or people like Dave Dvorkin to come, and they've never actually made the trek.
Well, I have a feeling Alex would enjoy it.
Yeah, I think so. So, okay, I'm going to share this. All right, let me try this one. Here we go. This is a bit easier. It's easy to share the browser. So you see the browser page. So this is planet4589.org is my website. So planet4589.org space GCAT is the general catalog of artificial space objects. And it has all kinds of, it's finally managed to actually document it. And so there are all kinds of stuff in here. There are launch lists. So for example, if anyone has a favorite rocket, let's look at the Veronique French sounding rocket. It has a list of all those launches. And then it has the object catalogs, which is the main catalog is the SATCA that I already have been showing you. Sorry, here we go. Starting with Sputnik and going down to the present day.
Oh, by the way, that reminds me. So yeah, okay, I see the answer to my question right there. So obviously Starlink has been kind of dominating the object.
Yeah. Let's get back to this address. So this is the deep space catalog that has all of these weird, obscure objects that went into deep space. So the most recent ones I've got include the lunar flashlight and the objects associated with the Hakuto R mission. And after this meeting, I'm gonna add in the ESA JUICE orbiter that just got launched this morning.
What is the Rashid rover?
So that is United Arab Emirates lunar rover. That is a micro rover, a bit like Sojourner, if you remember Sojourner from the 90s, the Mars thing. And it's attached to the Japanese commercial Hakuto R.
SpaceX launched recently.
Yeah, that was a SpaceX launch in December. They've now got Hakuto R into a 100-kilometer low lunar orbit, and they're going to try and do the landing in about a week.
The Emirates, by the way, I've been looking into their space program, and they're moving fast.
Yeah, no, and that's one thing. My interest in deep space cataloging and deep space SSA is finally getting some interest from other people. And part of that is after half a century where everything in deep space was either basically JPL or Institute Kosmiczego Islowania, that now you have the UAE is going into deep space, India is going into deep space, and commercial companies are going into deep space. And so you have all these different actors. And so sorting out the governance of deep space becomes now critical with things like planetary protection. And if you're going to do governance, you need to know what's going on. So you need a catalog, you need SSA, you need a registry. Our mutual friend Jesse Cade is trying to aid for a lunar registry. And I think that's just the beginning of that kind of work. And so my work to try and document the history of junk that we threw out there is sort of, I think, topical for that reason. It's also been useful. So you throw out a deep space probe and you throw out a rocket stage with it that ends up in orbit around the sun. And 20 years later, that rocket stage comes back near the Earth for a while. And the asteroid astronomers catalog it and go, oh, we found an asteroid that's a near-Earth asteroid. And then they work the orbit back and go, that's odd. It visited the Earth in 1974 pretty closely. I wonder what, and so I'm providing a finding list for them of candidates of if this isn't natural, if it's really space junk, what could it be? And there's really no other place to look that up right now.
And do you integrate a propagators so that you can do reverse propagation?
I have not done that at this point. And so I work with so there are people like Bill Gray and a few others who, and John Giorgini at JPL, who have sort of the propagation capability that can do these matches. And then what I can do is I can provide you with, okay, there's this obscure document that said that the last known state vector for this thing was this. So if you can propagate it back and match it, that's a good.
Right. Somebody should ask ChatGPT to write the code for all that. So what about commercial new space or whatever, or just contemporary operators? Do they make inquiries? Do they have any need for your specialized information?
Yeah, some do. I mean, for example, I have one of my derived catalogs is Where is Everything in Geostationary? And some of them use that just as a quick reference for seeing what's near their satellites. And I get queries. I would say the bulk of my queries are from journalists. And I get journalist queries at the rate of several a day. But I get queries from space agencies and companies just trying to ask some trivia questions that they need answered to and want to reference. So, or sometimes it's a matter of me pointing out that one of their objects is not the one that Space Force thinks it is. Sometimes Space Force catalogs 4 objects, but
Oh yeah. What do you do about ambiguities? Like, for instance, at Planet Labs, we have a famous story about the Russian. We launched a bunch of doves on the Soyuz, and like somehow, and it's kind of out of scope for this discussion, the Russians claimed that they deployed one of these doves at a certain time, and we're like, no, that's not one of ours. Ours is over here. And they're like, you know, and so there's kind of disagreement. Like, what do you do in that case?
Yeah. So what I do is this. Typically so there's particularly in the last 4 or 5 years, there's been a large number of objects, which if you go to the Space Force catalog, they're just like object A, object S, because they don't know what it is. But typically we're tracking 5 objects and we know there are 5 satellites. We just don't know which satellite is which object. And so what I do is I have a field, like at the bottom of this page I'm sharing right now, where there are little question marks next to the Jilin-1 satellites.
Right.
And that question mark is a flag that says, no, actually, I don't know which is which, but I've put them in. I've got 5 slots and 5 satellites, and I'm putting them in randomly so that the total statistics come out right. I have the right number of Chinese satellites and I have the launch data right, but I don't, what the question mark says is the mapping from this catalog entry to a particular TLE catalog number may not be right. And so that's sort of a compromise that's, I'm trying to think of a more interesting, that mostly it's the Chinese ones, but there are still, particularly the transporter launches, right? Here's the January transporter launch. And there's still about 4 objects that aren't identified that failed after launch. The launcher orbiter, the Epic Aerospace Chimera, never phoned home. And so they don't know which is which. And so I've just filled in the empty slots with the missing satellites at random and tagged them with this question mark to say, no, we don't know. And that's and that ensures that the total statistics come out right, even if the individual ones aren't known.
Okay. And then I'm going to do, I think, my last question that I have on top of mind, because we're closing out on the hour actually. So you've got the databases, and you've got the computer databases, and you've got the library of
I think the way this question's going, but yeah, go on.
So 2 questions. Other than the fact that you can go look up the rocket and you can go into your library presumably and find the binders as you've shown us. Is there any idea of how to make that more accessible? And this is, I know you're probably sick of this question. Would you consider allowing, say, the Internet Archive to
Absolutely. Okay. Yes. No, that's the obvious thing, right? Is that either the Internet Archive or Google.
Use the archive.
Okay. Yeah. But someone who has experience with scanning large amounts of crap needs to come in here with a team and just scan the whole thing. And I am totally down for that.
Right. As long as you don't have to pay for it
myself, and I don't have the time to do that.
Yeah. Okay. We have one more question, and then we'll end here because John Karsh has a good question in the chat. Outside of classified information, is there any info you'd really like to get, but it's hard to get?
Yeah. So hang on, let me just find okay. I lost the stop share button for a minute. Here we are. Here I am again. Yeah. So I'm going to go back to the deep space stuff. Stuff I really want to get is state vectors or orbital parameters for stuff on escape trajectories or in solar orbit or in lunar orbit. And particularly for rocket stages, right? So right now, today, they launched JUICE. We have a nice trajectory for the JUICE probe on the JPL horizons. We don't have any separate data for the upper stage, which will, after a avoidance burn, right, will be in a slightly different orbit. And we're hoping that asteroid astronomers will pick it up and give us an orbit for it. But it would be nice if there were a repository, and particularly for commercial missions, right? We don't need the Hokuto R probe about to land on the moon. their PR stuff gives just finally gave the orbital heights, but they aren't giving the orbital inclination, much less the rest of the orbital parameters. And so that's what I would like is any documents, even really old ones from the 60s, which give trajectory data for the deep space stuff. That's my favorite, the thing that makes me happiest when I get another one of those.
Okay, well, we're at the hour here. Allison, is there anything you'd like to close with?
Let me just say another thing. There's lots of other data. If you don't have that data, but you have other data, that doesn't mean I'm not interested.
If we hear of any NASA libraries that are decommissioning their collections, we should let you know.
Yes, indeed.
I might have some stuff for you. I will look around with that in mind.
Awesome. Thank you so much.
Yeah, you might also look into what John Menkins has in a garage that he maintains on his property out in California.
Uh-huh.
There's a huge library of stuff. He just grabbed everything he could as he was leaving NASA, and it's not well organized. Do you know John Menkins?
I don't know.
Okay, yeah.
Who is he on?
John Menkins came out of the Advanced Programs Office at NASA headquarters. He's best known for his work in solar-powered satellites.
Uh-huh.
But he was
space solar power.
Space-based solar power. That's his hobby, and what he wishes to be his avocation as well. I mean, his vocation as well. But he came out of NASA headquarters. He was one of the inventors of the TRL system, one of. But he came out of NASA headquarters 70s, 80s, early 90s, and he's got this huge garage full of documents that he's been trying to organize. It might have some source material you'd be interested in.
Yeah, that's possible. It sounds like he'll have a lot of more future-looking documents rather than this is what we actually.
Maybe not. He's very NASA. He's very NASA-centric.
Yeah. You know. So yeah. I'm always happy to kind of dig through someone's pile of stuff if I manage to get out to that.
Okay. I'm not sure if we just lost Allison or not, but if we still have her, Allison, is there anything you want to close with? Oh, well, I know what Allison usually closes with, but we've kind of already done it because John asked the question, "How can we help you?" And you've given us some pointers. So yeah, anything else, Allison? I say you're back. All right.
It's wonderful. Thank you, guys.
Yeah. Thanks everyone. Tell your friends, because I want to have more people tell your friends about the videos and to send a message to Lydia to get on the invite list. Hi, Lydia. Thank you so much for your help on all this. It would be impossible without you, and it'd be impossible without you, Allison. And thank you very much, Jonathan. This was fantastic.
Thank you for having me.
See you next time.
See some of you in my library sometime.
Indeed.
Absolutely.